Imagine being a detective, unraveling the mysteries of the universe. You've got your suspects, stars, black holes, and even rogue planets. But just when you think you've got it all figured out, along comes a new character that defies all the rules and makes you question everything you thought you knew. What if I told you these cosmic rule breakers could reveal that our fundamental understanding of space-time is, well, wrong? Sounds crazy, right? Or is it? Let's start by laying down the framework. Space-time is like the ocean of the universe. In this cosmic sea, we've got different kinds of fish, stars, planets, and black holes. These fish create currents and ripples. The bigger the fish, the stronger the current. Einstein's theory of general relativity taught us to think of these currents as the warping of space-time. Large objects, like stars and black holes, create strong currents that draw other objects towards them. But what if, just what if, our ocean has some mysterious, rule-defying creatures lurking in its depths? Creatures that don't just swim with the current, but create their own unique ripples, challenging our understanding of how this cosmic ocean actually works. What if some of these creatures reveal that our knowledge of this cosmic oceanic tapestry of space-time is, well, incomplete or even wrong? To uncover the identity of these mysterious entities that defy the norm, we need to set our sights on quasars. These perplexing cosmic phenomena are causing scientists to rethink some fundamental principles. But let's not get ahead of ourselves. The real voyage of discovery consists not in seeking new landscapes, but in having new eyes. Let's open our eyes to quasars and figure out what they're trying to tell us. Now, quasars are not your typical neighborhood stars, or even galaxies. They're far more enigmatic. A quasar, or quasi-stellar object, is an extremely bright and energetic center of a young galaxy, typically powered by a supermassive black hole at its core. Sounds intense, right? It is. In fact, some quasars outshine entire galaxies, so you might be wondering, if they are that bright, they must be pretty close, right? Well, actually the opposite is true. These luminous beasts are often billions of light years, which means that what we're seeing happened billions of years ago. We're essentially looking back in time, peering into the universe's distant past. But here's the kicker. While their brightness fits nicely into our equations, other aspects of quasars have left scientists puzzled. For instance, their energy emissions with the space around them are not completely in line with how we expect objects to behave in our so-called cosmic ocean of space-time. And what's even more perplexing is how quasars affect their surroundings. Imagine a single creature in our earlier ocean analogy, not just causing a ripple, but creating an entire whirlpool of questions and unknowns. And those questions? Well, they lead us to a startling possibility. What if quasars reveal a crack in the very foundation of how we understand spacetime? To dive deeper into the scientific enigma, we have to venture into what exactly we got wrong. All right, we've reached the point you've been waiting for. Drum roll, please. What did we get wrong? To understand that, let's talk about the biggest curveballs that quasars have thrown at us. First up, redshift. We've used redshift as a cosmic measuring stick, gauging how fast objects are moving away from us. It's like listening to the pitch of an ambulance siren change as it speeds past you. But quasars? Their redshifts are off the charts, and this should imply that they're zooming away from us at unimaginable speed. Yet, their brightness doesn't match this high-speed retreat. Something's fishy, or should I say, quasar-y. Next, energy emissions. The law of physics predicts a certain limit to how much energy an object can emit. It's like a speed limit sign on a highway, but for emitting energy. But quasars laugh in the face of this limit. They're the cosmic rebels, seemingly defying laws that we thought were universal. And let's not forget about their mass distribute. The centers of quasars, which are often supermassive black holes, appear to be more condensed and energetic than we'd anticipate based on our existing theories. If our cosmic ocean of spacetime were as predictable as we thought, these peculiarities shouldn't exist. So what's the deal? Are our laws of physics broken? Well, not exactly, but they might be due for a cosmic overhaul, a refinement that takes into account these baffling behaviors. Because when a mystery, like quasars, stares us in the face, it's not just a question, it's a challenge. a challenge to dig deeper and revise our understanding of the very fabric of the universe. And you know what's the most exciting part? This isn't the end of the story. It's just the beginning. The unknown is not a void. It's an invitation. And it's in the unknown where we'll find our answers. So we've been on quite the cosmic roller coaster, haven't we? We've seen how quasars are like these cosmic enigmas that challenge our established theories of space-time. But you might be asking, haven't scientists tried to fix this? Oh, they've tried. Let's talk about some attempts to reconcile these discrepancies and whether we're still, perhaps, getting it wrong. First on the list, modified theories of gravity. Some have suggested that maybe, just maybe, Einstein's equations need a little tweak. Various adjustments have been proposed, but most still fail to account for all the odd behaviors that quasars display. It's like trying to fit a square peg in a round hole. Something's just not quite right. Then there's the idea of exotic matter, the elusive stuff of science fiction. But could it be science fact? Researchers have postulated that perhaps the extreme conditions around quasars might involve forms of matter and energy we're just not familiar with. While fascinating, these theories are still in their infancy and face some scrutiny. They're like a new kid on the scientific block. Interesting, but not quite accepted. And what about the hypothesis that quasars are younger, quote-unquote, black holes, going through an adolescent phase of sorts? This would mean they behave differently than their older counterparts. It's an intriguing notion, but one that complicates our models even further. It's as if every answer leads to a bunch more questions. Despite these earnest attempts, none have fully reconciled the strange phenomena we observe in quasars with our existing understanding of spacetime. So, are we still getting it wrong? The candid answer is we don't really know. And that's both unsettling and exhilarating. We may not have all the answers, but each failed attempt is a stepping stone, a guide pointing us towards a more complete understanding of the universe. We may not have solved the puzzle, but we've certainly found some very interesting pieces. And as we keep questioning, who knows what other revelations await us? Because in science, every question is a doorway, and behind each doorway, well, the possibilities are as infinite as the universe itself. So we've ridden the ups and downs of this cosmic roller coaster, exploring the mysteries of quasars and even questioning our understanding of space-time. We've seen how past attempts to reconcile these perplexing phenomena haven't fully hit the mark. But what now? Where does this all lead? Firstly, new observational tools. As technology advances, we're getting telescopes and instruments that can peer further and more accurately into the universe. With these tools, we might just catch quasars in the act, revealing behaviors or properties that can plug the holes in our existing theories. Imagine a detective finally getting that key piece of evidence. That's what these tools could finally provide. Second, collaborative science. The puzzles presented by quasars aren't just for astrophysicists to solve. They intersect with particle physics, quantum mechanics, and even philosophy. More interdisciplinary work could help us create a more unified and accurate model of the universe. Think of it as different musicians in an orchestra, each playing their part to create a harmonious symphony. And finally, you. Yes, you, the person watching this video right now. Public interest and awareness in such cosmic phenomena can drive scientific inquiry forward. Your curiosity, again, you, the person watching this video, can be the catalyst for new studies, funding, and maybe even the next big discovery. After all, today's questions are the seeds that sprout tomorrow's answers. Is our current understanding of space-time wrong? Maybe. But being wrong isn't a dead end. It's a crossroad. A crossroad that leads to new avenues of exploration, learning, and understanding. And who knows, the next turn we take might just lead us to answers that are not only correct, but revolutionary. As we venture into these uncharted territories of space-time and quasars, one thing is for sure, the journey is far from over. The universe still has many secrets to tell, and we've got the best seats in the house for this cosmic show. Thank you for watching. If you enjoyed this dive into the world of quasars, be sure to check out the video on screen next. It's another wonderful journey into the cosmos that I'm sure you're going to love. We'll see you next time.